Hello. This question is about the simple harmonic motion, and on the screen you can see the velocity time graph of the particle which is executing the simple harmonic motion. Now, since they have said it's a simple harmonic motion, there are various examples of simple harmonic motion, and one of that I will show you on the left hand side of my screen. So the simple harmonic motion is a special case of oscillatory motion in which acceleration is directly proportional to displacement, but always directed towards equilibrium position. So this velocity time graph shows us that at the time t is equal to 0 seconds, the velocity of the particle is maximum right at that point, which means it is maximum negative. And one of the famous example of SHM that I'm going to show you is the mass spring system, horizontal mass spring system, which you can see on the left hand side. So I've shown you the different the mass spring system setup, which is actually showing you the different positions. I will talk about them later. So right now, this is our equilibrium position, and this must be the positive extreme position, and this must be when the mass will have a negative on a negative extreme position. So right now you can see that going to show you the position of the mass at equilibrium position. Velocity can be only maximum, either it's positive or maximum negative can be at equilibrium position, and it shows us that the the motion is towards left. So by the way, what we have to do in this question, we have to draw acceleration time graph, which will be one of them. So let us see. So so in order to check the acceleration time graph, that how the acceleration will change, first of all we should give the values of time, right? Because this is a half cycle, so I would say it is t by 2, right? So the same is here, it's t by 2. So and here is the one complete cycle, one complete oscillation is completed. So this is t. Don't you think that whenever the object is at equilibrium position where the displacement is zero, it means that acceleration is also zero, because acceleration is directly proportional to displacement. It means that our graph will start from the origin. Either it will be a positive sign or it will be a negative sign graph. We will decide it later. Secondly, if you notice, at that point, if I draw a tangent at that point, so the tangent is a horizontal line. So if I find here the slope or the gradient of the velocity time graph, that gives me a zero value, which again shows us the same concept that acceleration must be zero at the time t is equal to zero. Now let's talk about this point. At this point, dear students, which I can say the instantaneous time is t by 4, right? T by 4, and since the object is moving leftward, so in that quarter time this object should be exactly at the extreme position, means that at this position. And don't you think this is a position which we say is a negative extreme position, so where the displacement is maximum negative? But since the acceleration is directly proportional to displacement, but it's in opposite direction always, so it means that at that point, the acceleration must be positive maximum value, which is exactly endorsed from the graph when you try to find out the gradient. So I will show you this, that this is the tangent line, and this tangent line has a maximum slope or gradient, which means that the acceleration has been started from, I mean, increasing from 0 to the maximum positive value. So that I will exactly show you here. This is acceleration time graph, and right at that point you can see acceleration is going like this. So which means that all of the options, like B is wrong, C is wrong, and even D is wrong. So option A is the only right answer. But please, before you leave the video, just quickly see the other positions. So next position is this one, and notice that tangent line is horizontal, which clearly means that acceleration must be zero. It means that this graph is now confirmed it's a positive sine graph, and that will go on like this. So it's two cycles. And how the particle will change its position? So these are the different positions, and I'm going to show you exactly the instantaneous times as well. And after 1/4 time, it will return back to its equilibrium position, and that will be a completion of one oscillatory motion of this SHM. And these are the graphs, and I hope you understand the whole answer.